Okay, so today we're going to be talking about gears, pulleys, and sprockets. So in this first thing, I want you to kind of see the difference between some of these. So this is a gear. We're going to call this a gear train actually, because there's multiple gears here, but this is a gear train. You have down here, if you look closely, this right here is a pulley, like it's a pulley belt system, and a sprocket looks like this right here. You can think of them on bikes, or in this one it's on a motorcycle, it looks like, but that's a sprocket where you're using a chain. So a couple of things with all of these is that you can, and they all kind of fulfill one of these purposes. They can either change the speed of rotation, they can change the direction of rotation. We're going to show you how when you use either gears or sprockets, you can actually change the rotation. They rotate in opposite directions, or it changes the amount of torque available to do the work. Okay, I do want to say something that you guys will encounter is that torque and speed are related inversely with one another. Torque and speed, that's just in general. Okay, so talking about a gear train is a mechanism used for transmitting rotary motion and torque through interlocking teeth. So gears look like this. We're going to have small gears, we're going to have big gears. In fact, you guys are going to see these on your simple machines if you haven't already. This week we're going to be measuring the simple machine builds in class. We're going to be measuring some of the different torque and speeds related to your gear trains. So a gear train is made when two or more gears are meshed together. We're going to be calling one of them the driver. That's the one that we actually have the motion on, so we're putting the force on that one. So if I was driving with this one, I was putting force on this one, it would spin this larger one. Okay, that's the driven gear. So looking at the next slide, we kind of have that motion going here so that you guys can see. So in this one, you'll notice that the bigger gear is spinning slower than the smaller gear. That will always happen. So the other thing you should notice is that these mating gears are spinning in opposite directions. So that can pose a challenge. Sometimes you want your gears to rotate in the same direction. Think about wheels maybe on a tire, or some mechanism in the engine of a car. If we want them to spin in the same direction, we sometimes put in what's called an idle gear. This red gear right here is an idle gear, meaning that all this is doing, it's not providing any torque, it's not providing any mechanical advantage. What it's doing is making these two blue ones spin in the same direction. They're now spinning in the same direction. So that's called an idle gear, when there's one in the middle and it's not really serving a purpose. Okay, okay, next one, so you can see more gears. This, on the other hand, is different. This one, you'll notice that if this is the driver, okay, the driven gear maybe is our red one. And you could obviously go opposite on this depending on what you want out of your machine. This one is spinning slower and it's spinning this faster. If you want something to spin fast, if you want to rotate something slowly and have it spin fast, gears are great for that. You can use a gear for it. On the flip side, less frequently used, but sometimes as well, if you want to put the effort, so now my driver is going to be this red gear, and this is the driven one. If I spin that one fast, then this right here would spin slow. That is going to, by the way, create a torque situation. So that's kind of the inverse relationship between the two. So now we're going to be talking about gear ratios. We're going to be talking about gear ratios here. There are many ways we're actually going to see on the next slide that we have a lot of different formulas for that. You can use the number of teeth in order to get a gear ratio. You can use the diameter of your actual gears to get a gear ratio. You can use the angular velocity, or the speed to get a gear ratio, or you can use the torque. So that's what's really nice, is that gear ratios, given really any of these four, you can calculate a gear ratio. Okay, let's go on and see the equations, because there is one that should stand out. If you look, we have our gear ratio is equal to, this N is the number of teeth out, so you always take your output over your input for the number of teeth. Okay, output over your input. So if this, on this one, it looks like what they're doing is they are saying that this is the driver, Okay, this is the driver. The smaller gear is the driver, and this one is the one that's spinning. So they're putting their motion on this one, and this is the driven gear. If that's the case, then you're gonna see that you put your output number of teeth, 12 of them, over your input number of teeth. You put your diameter, okay, your diameter, which happens to be 4 on this one, over the diameter of the input. Okay, so out over in, out over in. This is the one that stands out. If you look here, this is where you're calculating speed, right? That funny W is speed. It's angular velocity, which is speed. So on that one, you do the opposite. You take your 40 divided by your 20. So you take your input speed over your output. That's the only one that's in that order. Torque, you do out over and in again. Okay, so this is good to know, but you also have it on your equation sheet. Okay, so something else about these. Sometimes, so we're gonna find out when you are calculating gear ratios, you always do out over in when you have number of teeth. Like even in class, we're gonna be doing that same thing. You do out over in. And then you're gonna end up multiplying all of those together. This train, I want you to see this is a gear train, and they're all touching each other. They're all spinning. I want to show you the gear ratio in this one. The way that I would calculate it is I would take B over A. Okay, B over A. Remember, I'm driving. This is my driver. My A is my driver. So I'm going to take B over A. I'm going to take 12 over 20. That's 0.6 to 1 is my gear ratio. I now have to do this gear ratio as well. So I do C, because again, now this is my driver. It's driving this one. So C divided by B, which is 5 divided by 12, I get 0.42. Then I do my last one. I do 20 to 5, which gives me a 4 to 1 gear ratio. What we do with these gear ratios is we end up multiplying those all together. So I take 0.6 times 0.42 times 4. Okay, those were the 3 gear ratios that I just got, and I get a 1 to 1. I want you guys to notice that if I had just taken this output and divided by this input, I would have actually got 1 to 1 as well. That's not just by chance. When you have this kind of gear train right here, these idler gears, idler because they're in the middle, they're just providing space really is all that's happening here. Those idler gears are actually not doing anything for you. These will be spinning at the same speed. It's a 1 to 1 ratio. They'll have the same amount of torque. It's really not creating any kind of advantage for you. Okay, so that is something to note. Now in a minute, we're going to see compound gear trains. In fact, I'm going to skip these slides so you guys can go back and take notes on these. This is the same concept that we had before, where if you have a compound machine, what you always do is take the mechanical advantage of one of them and multiply by the mechanical advantage of the other one. So that's how you would find a mechanical advantage if you have a compound machine. But I'm actually going to skip those. Like I said, you can take notes on those on your own, but I want to stick with the gears. So in this one, we found out that those idle gears in the middle did not make a difference. And now I want you to see this visual. This visual is very different. On this one, they're not together. So they're not like this, okay, where they're fed into each other, right? They're not in that scenario where they're fed into each other. Instead, in this one, you have them stacked on top of each other. Well, that is a different situation. In this one, if you took this small number of teeth divided by the big number of teeth, you would come up with the wrong gear ratio, okay? So let me show you how we calculate these. It's really no different, but these share an axle. So that's the first thing that you should notice is that these are on the same axle, B and C. You have this is stacked behind it. That's really what's going on here. This is called a compound gear train. A compound gear train because they're stacked on top of each other. In this one, you do have to go through and calculate the ratios. So I would take my 20 over 50 because again, in this one, I'm gonna assume that my driver is actually, oh wait, what are they doing here? Are they doing the driver between A and B? Yeah. Oh wait, A and B. Okay, so they're doing it that way. So this one actually, the driver is A. I'm just now seeing that. So it's not on D. That would be a different gear ratio. It actually would be a 1:10 ratio, but I'll go ahead and do it the way that they're doing it. So the driver is A. If that's the case, then we go output divided by input. So we're going to do that 40, okay? 40 teeth is all I'm seeing on here. I'm not seeing diameter, so I'm going to use the teeth. So 40 is my output over 10. 40 over 10, which gives me a 4:1. I'm going to do the same thing for the next one. So the next one, I'm going to do my C, okay? My C and my D are going to now be, so it's going in this direction. So I'm going to take my D, my 50 teeth, and divide by my 20 teeth. I've now calculated the gear ratio for A and B and for D and C. Remember, these share an axle. Well, so now the entire gear ratio of this gear train, I actually am going to multiply those two together. I'm going to take the 4:1 ratio and the 2.5:1 ratio, and I end up with a gear train ratio of 10:1. Notice that in this one, had I gone just and skipped these middle two gears, okay, these are not idle gears. I want to make that clear. Because they're stacked, they're not idle gears. Idle gears, again, flipping back here, are in the middle of them. They're not stacked together. Okay, so in this one, if I took the gear ratio, I would have had 50:10. If I just skipped this whole middle part, 50:10, which we see as a 5:1 ratio. So we would have ended up with the wrong answer. This gear train actually does provide a lot more torque, okay, torque. Okay, let's go ahead and look at the belt and pulley system. It functions the same, except for obviously we don't have teeth in this because we're not talking about, when you have a belt and pulley system, you definitely don't want teeth. The belt runs over two spinning wheels is what you kind of have going on there. So instead, you'll be using those same exact equations that we were doing. Okay, you have your diameter out over your diameter in. Okay, you can use that. You can use the velocity, but remember that your speed, I'm sorry, not velocity, angular velocity, but your speed right here is in over out. That's the only one that is in over out. Or you could use your torque. So in this one, they actually show all of them. So the out, it looks like in this one, my diameter out. So my driver in this one, my driver is my little one right here. That's my driver. So it's always important because otherwise, remember, these relationships would be flipped. So you go out over in, 6 inches over 2 inches. Or for this one, you do in over out. So you would be doing the 30 RPMs over the 10 RPMs. These are all going to end up being a 3:1 ratio. You could use the torque as well. Okay, so nothing different there. These are all just examples of that. Guess what? Sprocket and chain system function the exact same way. You can use all of these, but sprockets have teeth again. So sprockets have teeth. The teeth are a little bit bigger. You guys are going to get to see in class that my gear train, it doesn't mesh. Obviously, if you try to put a sprocket right next to a sprocket here, they wouldn't mesh well where the gears do, but the sprockets have a chain on them. And again, we will encounter these in our simple machine builds at school. You will get to see a sprocket in action with a chain. Okay. This is the last little slide that I'll show here, but pulling pulleys and sprockets. A pulley has a belt where a sprocket has a chain. The advantage of a pulley, they're very quiet. Those are the belts. Those are in your car, they use them. In your car, they're not going to use a sprocket. They're not going to use a sprocket in your car because it would be very, very noisy in your car, right? You don't want something clanking around. The pulley system, the disadvantage is that they definitely can slip, like the belts can slip off. The belts wear a lot easier over time. You may have heard like getting a timing belt in your car replaced. That's definitely something that can happen. So there are some disadvantages to the pulley systems with belts. But there are also disadvantages with the sprockets. Sprockets are way more expensive because you're dealing with a chain instead. You need lubrication, they're noisy, so there's also disadvantages to that. Okay, and that is all for pulleys, belts, and gears.